Hi everyone. So today I am going to be walking through with you the cardiac cycle. Specifically, we're going to be looking at the four major phases of the cardiac cycle, which consists of ventricular filling, isovolumetric contraction, ventricular ejection, and isovolumetric relaxation. Before getting started, it's important to understand that we have to understand the relationship between volume and pressure. And specifically, we can look at this in regards to the heart. When volume of blood is increasing in a closed space, the pressure would also proportionately increase. When volume is decreasing within a closed space, our pressure would proportionately decrease. It's also important to understand the definitions of systole and diastole. Systole refers to ventricular contraction, and diastole refers to ventricular relaxation. So here we see that this diagram shows four major phases of the cardiac cycle. Phase 1, which is our ventricular filling. Phase 2, which is our isovolumetric contraction. Phase 3, which is ventricular ejection. And Phase 4, which is isovolumetric relaxation. And then we go back to Phase 1. We also see that we have clear imaging of which valves are open, our AV valves or our semilunar valves, which I'll explain the significance of this momentarily. Phase 1 and Phase 4 are both forms of diastole, meaning we are in ventricular relaxation. Phase 2 and Phase 3 are both systole, meaning our ventricles are contracting. In Phase 1, or ventricular filling, blood from the right or left atria will begin to fill into the right or left ventricles. In order to do this, the right and left AV valves must be open so blood can flow into the ventricles. However, our semilunar valves are closed. AV valves and semilunar valves will never be open at the same time. They could be closed at the same time, but you'll never see them open at the same time. When blood begins to pour into the ventricles, which we see the blood volume here, we see pressure here. Since we know that volume and pressure are proportionate with one another, we can assume that when we have an increase in pressure, we're having an increase in blood volume. So over here, our blood pressure is slowly increasing, which means our blood volume is slowly increasing within the ventricles. That is our ventricular filling, one of our diastolic phases. It's also important to note that at the end of Phase 1, we call this an EDV, or an end diastolic volume. It is at the end of Phase 1 where the volume of blood will be the highest in the entire cardiac cycle. And a cardiac cycle is simply defined as all of the events of blood flow happening within the heart in a single heartbeat. Moving from Phase 1, we enter Phase 2, isovolumetric contraction. As you can see, pressure is substantially rising from our ventricular filling stage to ventricular contraction stage. Because we're having ventricular contraction, we would call this stage a systole. It's important to note, though, that even though we are having an increase in pressure, our volume is still remaining the same. The only thing that is switching is the space within the ventricle. The ventricles are physically contracting, so if our space is decreasing, but our volume is remaining the same, we're going to have a huge spike in pressure. This spike in pressure is also contributed because our AV valves and semilunar valves are both closed. After isovolumetric contraction, we're going to move to Phase 3, which is ventricular ejection. As the name suggests, the blood is going to be pushed out through the semilunar valves, whether it be the aortic semilunar valve going to the systemic circuit or the pulmonary semilunar valve going to the pulmonary circuit. Regardless, though, of where the blood's flowing, semilunar valves will be opened, but the AV valves will be closed. It is during phase 3 where we have the highest amount of pressure occurring during the cardiac cycle. It's also, though, where that pressure begins to decrease. So we go from an increasing pressure to our maximum pressure to a decreasing pressure. It is also at the ends of phase 3 where we say that we are in an ESV, or an end systolic volume, which is basically a fancy way of saying that we have the minimum amount of volume present within the left ventricle of the heart. I don't know if I said it before, but EDV and ESV are both referring to the left ventricle. So the volume of blood within the left ventricle. An EDV has the maximum amount of volume within the left ventricle, and an ESV has the smallest minimum amount of volume within the left ventricle in a given cardiac cycle. Finally, we move to phase 4, isovolumetric relaxation. In this stage, both the AV and the semilunar valves are closed, and the volume of the blood remains the same. Because phase 4 is a relaxation, we say that we are in a diastole, which means that we're not contracting, but we are relaxing, and our ventricles will open up and have more space. Therefore, we have a substantial decrease in ventricular pressure. This cycle will continue continuously from phase 1 to phase 4. Again, ventricular filling, isovolumetric contraction, ventricular ejection, and isovolumetric relaxation. If it helps to have a visual, you can see at the bottom of this slide, we have phase 1, phase 2, phase 3, phase 4, which is simply referring to the graph that we had back on the previous slide over here. So all this is showing is during ventricular filling, we have our right atria with a greater amount of pressure than the right atria has a greater amount of pressure than the right ventricle. Therefore, that difference in pressure would cause the AV valves to open. It's also important to note that atrial contraction will also occur near the end of ventricular filling, kind of to squeeze that extra blood content into the ventricle. We then enter isovolumetric contraction, and notice how the AV valves and semilunar valves are both closed compared to ventricular filling. Ventricular ejection, now the AV valves are still closed, but our semilunar valves are opening, as we are ejecting the blood into either the pulmonary circuit or the systemic circuit. And then finally, for isovolumetric relaxation, we have our semilunar valves closed and our AV valves closed, and our ventricles are then relaxing. And we have our minimum amount of volume in our left ventricle. Notice how at the end of the ventricular filling, we have the highest amount of blood volume, which is our EDV, and at the end of phase 3, we have our lowest blood volume, our minimum blood volume. The cycle will then repeat, in which we go back to phase 1. And notice that during these other phases, the atria are starting to fill up with blood, whether it be from the systemic circuit or the pulmonary circuit, so that by the time we get back to phase 1, we have so much pressure within the atria that we can open up our AV valves to allow for blood flow into our ventricles. Finally, this is another diagram to show the cardiac cycle of blood flow within the heart, where we have the stage A being our ventricular filling, a diastole. We have phase B being isovolumetric contraction. Same volume as you can see here, but we are drastically increasing our pressure, as you can see on the y-axis. And then phase C, where we have ventricular ejection, where we're not increasing volume. In fact, we're expelling our volume, and then we kind of increase, and then we stop, and then we begin to decrease, and then we get to phase or stage D, where we're in isovolumetric relaxation. Our volume is still remaining consistent. That's why we have simply a vertical slope here, but the pressure is drastically decreasing. So I hope this video helps understand the cardiac cycle, and leave any comments in the comment section if you have any questions. Thank you.